Can you talk about void coefficient and how reactors operating today are different from Chernobyl? That's a great question, the void coefficient. If you saw the Chernobyl series, you'll hear that towards the end there. And the void coefficient is something that's required by law. It's always been required by law back in the United States and in Western designs. What that means is that when the reactor heats up, it drives the reactivity of the core down. So that's what a void coefficient. It's got to have a negative void coefficient. So if you start to get any bubbling or excessive bubbling beyond the design specification, it tends to shut the reactor down. The reactivity decreases so that you don't have a runaway reaction. Chernobyl, it had a positive void coefficient, which means when it heated up, the reactivity went up. And that was a large part of the problem, is that it had a positive void coefficient. And really what that means is you need a certain amount of water in there to have that negative void coefficient, so that if you have less than that, the reactivity is diminished because you need that water for the moderation. So that a little bit more water is good in terms of making the reactivity go up, but if you get any boiling, you don't have enough water and it just drives the reactivity further down. So that one way of saying it is the reactor is slightly under moderated. It needs a little bit more moderator, in other words, water, for the reactivity to go up. But you don't get that with water because it's really an incompressible fluid. And if you get any boiling above the design specification, if it's a boiling water reactor or if it's a pressurized water reactor, no boiling. And for the pressurized water reactors, if you have any void in there at all, bubbles, the reactivity goes down. A long drawn out way of saying something that's very simple, but we are talking nuclear engineering. So thanks for the question. Thanks for watching. Have a good day. Bye.